Now students, continue the D and F elements. That general properties of transition elements. Electrode potential of transition elements are D block elements. Electrode potential values of first row transition series means 3D series scandium to zinc. First row transition series gradually increases from left to right. Scandium to zinc increases from left to right with the same exceptions, but there is one exception, that is E0 value, standard electrode potential value for copper 2 plus for copper is positive. Copper only though having the positive values, that is the plus 0.34 volts, while other except copper, other elements in the 3D series, E0 values of all the other first row elements are negative, but copper showing positive value. This is the one of the exceptions. And this is because why copper showing the positive value and the rest of the elements in the 3D series showing negative values. This is because high energy to transform copper to copper 2 plus. The copper solid metal converts to copper 2 plus in aqueous solutions. It is not balanced by its hydration and enthalpy. It's not balanced by its hydration and enthalpy. So copper does not easily react with the acid and liberate H2. Rest of will reacts with the acid or concentrated nitric acid, sulfuric acid, liberates hydrogen gas, but it can't. Only the oxidizing acids, nitric acid, concentrated sulfuric acid reacts with the copper and the acid gets reduced. That is what are the some important cases in the electrode potential of transition elements. Along the series of the E0 values becomes less negative due to the increase in the sum of first and second ionization enthalpy. It is already learned in the previous class, ionization enthalpy of transition series. Sum of first and second ionization enthalpy. The E0 values of Mn2 plus means it loses the 2 electrons from the 4s orbitals, Mn2 plus. And zinc 2 plus, it loses also to 4s orbitals and are more negative. This is because of filled configuration and completely filled orbitals. Here Mn2 plus means it is completely off filled d5 configuration. Zinc means 3d10, 3d10 completely filled electronic configuration, so that they are having the more negative values. And E0 value for metals is the third ionization enthalpy. The value of scandium is very low. Scandium value of electrode potential is very low because in scandium atomic number 21, argon electronic configuration followed by 4s2 3d1. Third ionization means removal of 3 all the 3 electrons are removed. It means it forms a stable electronic configuration, that is argon. So E0 value for scandium is very low, and that for zinc. Zinc is show very high electrode potential value because stable electronic configuration. It is D. Like that. E0 value for manganese is high because it has completely off-filled D5, completely off-filled electronic configuration. And E naught value of iron in third ionization enthalpy is very low, because if you remove one electron from Ap2 plus 2 gives Ap3 plus, it means 3d6 converts into 3d5. 3d5 is a stable electronic configuration because completely off filled d orbital, so that it has very low value of electrode potential. Next, general properties. Magnetic properties of transition elements. Transition metals show mainly two types of properties, that is paramagnetism and diamagnetism. What is meant by paramagnetism? Transition metals showing slightly attracted towards the magnetic field, and diamagnetic means there is an absence of unpaired electrons, so that they repel or cancel to each other. There is no attraction to the magnetic field, diamagnetism. In the paramagnetism, there is unpaired electrons, so they likely attract towards the magnets. The some transition metals show ferromagnetism. Ferromagnetism means which is an extreme case of paramagnetism. After the extreme case of paramagnetism, transition metals are D group element or D block elements showing ferromagnetism properties. Number 1, paramagnetism. Paramagnetism arises in the presence of unpaired electrons. It is already we know that by writing the electronic configuration of 3D series, 4D series, there is available in unpaired electrons is increases from scandium to the manganese and then decreases. Then depend upon the unpaired electrons, it's showing paramagnetism. Each unpaired electron is associated with the spin magnetic moment. Spin magnetic moment and orbital moment. There are two: spin magnetic moment and orbital moment. For the compounds of first row transition elements, it is nothing but 3D series, scandium to zinc. For the compounds of first row transition elements, the contribution of orbital magnetic moment is effectively cancelled, and so only spin magnetic moment is considered. So how to calculate the only spin magnetic moment? Is calculated by using this formula. Spin magnetic moment is determined by the number of unpaired electrons. Mu s, here s is spin only magnetic moment, under root n plus 2, where n is number of unpaired electrons in the given first row transition element or first second transition element, where n is the number of unpaired electrons and u s is the spin only magnetic moment in the unit of Bohr magnet, Bm, Bohr magnet unit. The magnetic moment increases with the increases in number of unpaired electrons. Or the total number of unpaired electrons increases from scandium to the manganese. Maximum number of unpaired electrons are present in manganese, 5 unpaired electrons, and then number of unpaired electrons decreases. Iron to the zinc. For example, titanium. Titanium calculated the spin only magnetic moment for titanium 3 plus. Here oxidation state they given 3 plus. What is the atomic number of titanium? 22. 22. Scandium, titanium, Z. Now they give oxidation state 3 plus. Titanium electron configuration solution. Z is 22 means 4s2 argon followed by 4s2 3d2 3 electrons will loss of oxidation state 3 plus indicates these 2 plus 1. Only one electron, one unpaired electron present in the electronic configuration of titanium 22. Here, atomic number, this is the formula to calculate the number of unpaired electrons present in the given element. Atomic number of titanium, given element titanium, what is atomic number? 22. Minus oxidation state 3 minus atomic number of nearest noble gas argon 8. 22 minus 3 minus 18 is equal to 1. Number of unpaired electrons in titanium 3 plus ion 1. Here n is 1. Put a 1 is in the place of n, under root 1 into 1 plus 2. Under root 3 value 1.734 magnet is the answer. Like that, you have to calculate by using the calculate spin magnetic moment by using this formula. First of all, you have to calculate the number of unpaired electrons by using this formula. N is equal to atomic number of given element minus oxidation state of the given element minus nearest noble gas of atomic number of the nearest noble gas. Calculation of spin only magnetic moment in respective element of elements are 3D series by using the formula. First of all, calculate the number of unpaired electrons in 3D series by using this formula n, where n is number of unpaired electrons is equal to atomic number of an element, given element, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, minus oxidation state. What is indicates oxidation state, loss of electrons. It is already represented in the form positive sign. Minus atomic number of nearest noble gas argon for 3D series. This is the formula. But if n is equal to 1, 2, 3, 4, 5, 1 to 5, n number of unpaired value must be 1 to 5. Means all are unpaired electrons. All are unpaired electrons. But if n value is more than 5, 6, 7, 8, 9, if they given 6, 7, 8, 9, then they are used by calculating 10 minus n. 10 minus n. If less than 5 means directly write 500 electrons, 400 electrons. If more than 5 means 6, 7, 8, 9, 10, then minus in the 10. 10 minus given unpaired electrons. Let us see examples. First example is C3 plus, scandium 3 plus. Atomic number of scandium 21. Then formula atomic number of the given element scandium 21 minus oxidation state 3 minus nearest noble gas for scandium argon 18. 21 minus 3 minus 18 0. 0 means it is diamagnetic in nature. Absence of unpaired electron, so it is diamagnetic in nature. Absence of unpaired electrons in 3D series. Scandium 3 plus does not contain any unpaired d electrons. So that it carries magnetic moment also 0 both magnet. Mn2 plus. Mn2 plus. Atomic number 25. Atomic number of the element 25 minus oxidation state is 2 minus nearest noble gas 18 is equal to 5. Now 5 is in between them. N value is 5. So all are unpaired electrons. 5 unpaired electrons. So it is paramagnetic in nature. Paramagnetic in nature. Which are the containing unpaired electrons? They show color. mu as under root n n plus 2 to calculate the spin only moment. Here n value is 5 unpaired electrons. Under root 5 plus 2, 5 into 7, it gives under root 35. 5.92 Bohr magnet is the value. Spin only moment for Mn 2 plus. This is the way to calculate. If n value is more than 5, then how to calculate 10 minus n? See, copper 2 plus 2 only. Loss of 1 electron only. Cu 2 plus. Atomic number of copper 29. Atomic number of copper 29. Atomic number of copper minus oxidation state 1 minus atomic number of nearest number gas argon. 29 minus 1 minus 18. 2 gives 10. Now n is equal to 10 minus n. N value also they given 10. Isn't it? 29 minus 10. 20 30 10 value. 10 minus 10 gives 0. 0 means there is no unpaired electron, so diamagnetic in nature. Spin only magnetic moment also gives 0. Cu 2 plus. Atomic number of copper 29 and oxidation state minus 2 and nearest double gas small copper 18. Answer is 9. 9 unpaired electrons. It means more than 5. So that we are using 10 minus n. 10 minus 9 is equal to 1. 1 unpaired electrons is present in the Cu2 plus. So Cu2 plus is paramagnetic in nature. It is value 0. Unpaired electrons, so it is diamagnetic in nature. Paramagnetic due to presence of 1 unpaired electron. Now calculate the spin only moment. Gives 1.73 Bohr magnet. Zn2 plus zinc sulfate. Zn2 plus for atomic number for zinc 30. 30 minus 2 oxidation state minus nearest moment electronic configuration argon 18. 30 minus 2 minus 18 10. So 10 minus n value also 10. 10 minus 10 0. It has 0 Bohr magnet. So it is diamagnetic in nature due to the absence of unpaired electrons.